Salam and good day to my honored lecturer, Madam Fatia, and all people who watch this video. My name is Laksmita Rosyidah Nalibrata from Petroleum Geoscience Department, University Technology Petronas, Malaysia. In this video, I would like to do the review paper presentation for basin analysis course. The title of the paper that I use is The Structure and Stratigraphy of Deepwater Sarawak, Malaysia, Implication for Tectonic Evolution by Madon et al. From Journal of Asian Earth Science. And first, let us start from the introduction. So the Sarawak Basin of Borneo, as shown in this figure, forms in the southern margins of the Oligocene recent South China Sea Basin, and its tectonic evolution is closely linked to rifting and sea floor spreading in the South China Sea marginal basin. By the mid-80s, geologists in the southern margin Sarawak, Brunei, and Sabah had ascribed to the idea that continental blocks that drift off South China had cooled with Borneo. And the Sarawak Basin have been interpreted as a post-organic foreland basin. And for the study area, the Sarawak margin has a shelf for over 300 kilometers wide and water depth ranging from 200 meters to more than 2,000 meters. And the study area is North Luconia is located in deep water north of the Sarawak Self. It is contiguous with the dangerous grounds to the northeast, forming the extended continental terrain of the southern continental slope of the South China Sea marginal basin. All right, so this is the schematic tectonic models for the evolution of the Sarawak Basin. So the first is late Cretaceous to Eocene, drifting of certain margin of the South China coupled with subduction of the Proto-South China Sea produced an Cretaceous complex which was later uplifted onshore. And the second is late Eocene to early Oligocene, the collision of Luconia block with Borneo at the end Eocene and cessation of subduction and deep marine sedimentation. Foreign basin developed on the rifted lithosphere while undergoing subduction. Spreading of South China Sea began. And the third is early Oligocene to early Miocene. Spreading of the South China occurred at 32 million years ago, caused an accelerated strike slip movement and a major uplift and erosion in the Rajang Fault Belt. All right, so this is the petroleum exploration history. So the North Luconia province is relatively poorly explored, with only 7 wells drilled between 1994 and 2012. So the first deepwater well in Malaysia is Mulu-1, was drilled in 1,165 meters and found only minor gas source. And the second is Bako 1 well in 1,112 meters and excellent quality sands but was dry. And the third is Lanjak 1 well down to 2,721 meter depth, and that well found very low quality sand with some gas shows. And the fourth is Jelawat 1 in 640 meters of water. And during that year, Newfield started its operation in the area and later drilled 2 wells. There are Talang 1 in 2006 and also the Paus 1 in 2009. And the last is appraised in July 2012 by the Paus North 1 well. For the tectonic framework, the Sarawak Basin is underlain by more than 12 kilometers of tertiary siliclastic and carbonate sediments, and the researchers subdivided Western Borneo into several tectonic zones. That young to the north, there are Kuching Zone, Sibu Zone, and Miri Zone, as shown in this left figure, and the seismic refraction and reflection data shows that the basement to the tertiary Sarawak Basin in the offshore extension of the Sibu Zone, which is formed by the upper Cretaceous to Eocene, Rajang Fault, and Frost Belt. And the Nyalo Formation comprised fluvio-estuarine and shallow marine, and the sequences deposited in the mixed wave and the influenced coastal deposit system, and the Sarawak margin is subdivided into several tectonostratigraphic provinces as shown in the right figure here. All right, so the extensional tectonic on the Sarawak Self, extensional tectonic is evidenced by normal faulting in the Balinian and Tatau Half Graben province, as well as the Central West and also the North Luconia province. So in the Tatau and Balinian province on the Sarawak Self, Oligocene to lower Miocene succession from cycle 1 to cycle 3 was affected by normal fault that generally terminate at the base cycle for unconformity. For the tectonic evolution, this is the schematic illustration of the late Cretaceous to early Tertiary subduction zone at the certain margins of the Proto-South China Sea of Rajang Sea. And the subduction beneath the Sarawak margin may have cased by late Eocene, but continue farther to the east and northeast into Brunei and Sabah. A second collision even between the dangerous ground block and Sabah resulted into the, we call it Sabah orogeny, which is generally thought to coincide with the end of seafloor spreading in the South China Sea. The accreditation complex of the deformed and uplifted deep sea sediment that make up the Rajang Fault and thrust belt, we can see in this figure. Next is the stratigraphy framework. So the sedimentation began with non-marine to coastal plain sediment that are cycle 1 to 3 and became more marine from cycle 3 upwards. And the cycle 1 sediments are regarded as the offshore subsurface equivalent of the Tatau and Nyalo Formation of Central Sarawak. And cycle 3 and older unit don't have onshore equivalent except in the Baram Delta region around Miri. For the stratigraphy of North Laconia, based on regional seismic data, researchers interpreted the stratigraphy of deepwater Sarawak, essentially compressing into two mega sequences. The first one we call syn reef and post reef. So the syn reef is faulted succession, which is correlated with the cycle 1 to 3 on the south, whereas the overlying post reef comprising non-faulted trapping strata is equivalent to cycles 5 to 7 on the south. All right, so for the early Miocene unconformity that I already mentioned before, this seismic evidence suggests that the early Miocene unconformity is strongly erosional as shown in this figure and represents a major break in sedimentation and or erosion. So the line 5 through Mulu 1 well shows the internal character of the pre-AMU sequences, and the line 6 across Baker 1 well and biostratigraphy results a transparent seismic facies above the top of syn reef break up unconformity 32 million years ago below TD at Baker 1 would represent a deep marine shell equivalent to that in Mulu 1. And this throttle pattern suggests that the EMU is highly erosion and cuts down to the upper Oligocenes that are 100s of meters of missing section. And the second is the post-EMU strata on the erosion surface and fill the hollows left the erosional event. The geological interpretation of seismic data. A seismic line across the area shows by a rift basement with tidal fault blocks and half-graben arrays overlain by a seaward thinning sedimentary prism of relative flat data. From the left figure, the seismic data shows two main types of reflection characteristic facies, and As shown in this right figure, the seismic profile line 3 running northwest to southeast near Bakuwan Well, where the post-EMU trap sediment is much thinner, away from the influence of the Rajang and Baram Delta. Okay, the following trends from deep to shallow marine was recognized from the biostratigraphy data from Muluwan and also Bakuwan. And the correlation between Muluwan and Bakuwan wells showing the main cycles 1 to 6 identified upper Oligocene deep marine shall overlies the synthetic sequences. Also, this is the generalized model of a peripheral foreland basin caused a propagating thrust belt, which may apply to Sarawak Basin. And next is free air gravity anomalies are useful indicator of the subsurface density structure of the crust and therefore potentially useful for testing hypotheses regarding to the tectonic evolution of continental margin and also the sedimentary basin. Next is data and method. So this well-established backstripping technique that use the same isostatic equation, but with an additional term that account for the effect of sea level changes and paleobathymetry. So this is the equation that used in the method. So based on previous studies, gravity modeling data calculation using several methods by the researchers and Madon et al., it resulted the backstriping for the self-wells well that are plotted as water-loaded subsidence with time, starting at 43 million years ago as the start of subsidence as shown in this figure. Although there is no assumption that the subsidence was due to drifting. For reference purpose, the overlay the theoretical subsidence curve based on the thermal model. Next is for the tectonic implication. The tectonic subsidence seems to indicate a rift type subsidence pattern as opposed to a foreland subsidence as previously proposed based on a smaller data set of self-well wells. Next is an regional content. The author interpret the closure of the Rajang Sea probably occurred in a scissor-like fashion with the deformation yanging progressively from the southwest to the northeast as shown in this figure. And the Rajang Sea might have been called a remnant ocean basin produced by a diachronous closure and uplift of Fleet belt from the west to east. Right. In conclusion, the structural stratigraphy history of the North Luconia province Sarawak deepwater area is related to the tectonic history of the South China Sea, and the Sarawak Basin initiated as a four-lane basin as a result of the collision of the Luconia continental block with Sarawak, or we call it Sarawak orogeny, and the four-lane basin was later overridden by a buried under the propagating Oligocene region slope system, and the basin had evolved through a deep four-lane basin that called Fleet phase during the late Eocene to Oligocene times, and followed by post-Oligocenes, or we call it Moles phase of shallow marine self-propagation to present day. And for the gravity modeling that indicates a thin continental crust underneath the Sarawak Self and slope and support the seismic and well data interpretation, there is a probable presence of overthrust wedge beneath the Sarawak Self, which could be interpreted as a silver of the Rajang group accretionary present. Alternatively, the magnetic underplating beneath the Sarawak Self could equally explain the free air gravity anomaly. And the present day, the Sabah margin may be a useful analog for the Oligocene Miocene Sarawak foreland basin. I think that's all for me. I'm sorry if there is still a lot of mistake that I explained. Thank you for your attention. Goodbye.